going to start off 7.4 by talking about separable differential equations. So, using separation of variables to solve first order differential equations. This technique can be used when all x terms can be collected with dx and all y terms can be collected with dy, and the solution can be obtained by integration. These equations are called separable differential equations, and the process of collecting terms is called separation of variables. And I'm going to use this example to explain what you guys just wrote down. So, solve the differential equation. Y prime is equal to x times 1 plus y. So just like the first video that you saw for chapter 7, I'm going to go ahead and rewrite y prime as dy over dx. So that's the same thing, I haven't changed anything. And now I'm going to go ahead and separate. Okay, just like the note said on the previous slide, I'm going to separate. And I'm going to collect all x's with dx's and all y's with dy. So if I multiply both sides by dx, I now have something like this. And then if I go ahead and divide both sides by 1 plus y, remember there's a 1 there. I have now collected all my x's with the x's and all my y's with the y's. And then, again, just like the note said, I can now integrate both sides. Okay, pause the video, try to integrate the left side, try to integrate the right side, and compare your answer with mine. So the right side, integrating x with respect to x, might have been a little easy. Should have been easier. But integrating 1 over 1 plus y isn't too bad. This is a simple u substitution. So if you let u equal 1 plus y, you now have the integral of 1 over u. And when you take the derivative of u with respect to y, you just get 1. So du equals 1 times dy. So you can just simply replace the dy with the du. You integrate this to get the natural log of the absolute value of u plus c, and then you resubstitute your values to get the natural log of the absolute value of 1 plus y plus c. Okay? Now, notice that we have two c values. Most textbooks or college professors will tell you to label them as C1 and C2. But for the AP test, we can pretty much combine them and say C1 plus C2 equals a constant. Okay? So whether you add or subtract, so let's say I do this. Okay, I do this, well, a constant minus a constant, that doesn't matter what they are, it will always produce another constant. So, on the AP test, you can just keep it as one constant. There it is. See, you don't even have to put it on the left-hand side. Okay? So, because of this kind of what's going on behind the scenes, but you don't even have to explain this part on the AP test. Okay? In other words, just stick with one C value. And I'll show you guys another example after this so you can kind of see what's going on with the C values there. But key is just stick with the one C value. Don't start confusing yourself by keeping two C's and so on. So the next step is I want to solve this for y. So I'm going to raise both to the power of e. So this is key, okay? Make sure you put parentheses when you raise both sides to the power of e. I did that because now I'm going to go ahead and get rid of the natural log and just have the absolute value of 1 plus y, which is equal to e to the x squared over 2 plus c. Now, we have 1 plus the absolute value of 1 plus y is equal to, this is the same as e to the x squared over 2 times e to the c. Now, keep in mind, e is a constant. Okay, so e is a constant. And we're raising pretty much e to a constant. Well, a constant raised to a constant is just another constant. So again, if you were keeping track of your c values, this would technically be c3. Or actually, if you call this one c3, this one would be c4. Remember that c1 plus c2 equals c3 in the previous steps. But we're not doing all that. The AP test lets you, without explaining, just keep everything labeled with C. Okay? So what I have is the absolute value of 1 plus y is equal to C times e to the x squared over 2. Order doesn't matter when you're multiplying. Now, the absolute value of 1 plus y is just a piecewise function. Okay, so the absolute value of 1 plus y is just the piecewise function of negative 1 plus y for values of y that are less than 0 and positive 1 plus y for values of y that are greater than or equal to 0. Okay, so all you have to do is bring out this plus or minus to get rid of the absolute value bars here. So we have 1 plus y is equal to plus or minus c times e to the x squared over 2. Okay, again, on the AP test, you can do it without explaining. I'm just refreshing your memory on this. And then finally, the final answer is y equals plus or minus c e to the x squared over 2 minus 1. That's it. That's your answer. All right, let's try another example. Find the function y equals f of t passing through the point 0, 10 with the derivative dy over dt is equal to 3 over 4y. So there are going to be a lot of cases, actually more cases, where we're given an initial condition. And remember, that just means that we can find a particular solution. Okay? So a more exact solution. Now let's go ahead and try this one. So again, we're going to start off by separating the variables, collecting all dy's and y's, this time dt's and t's. Okay, so when we separate them, I'm going to multiply both sides by dt. I get dy is equal to 3 over 4 y times dt. And then when I divide both sides by y, I then have 1 over y dy is equal to 3 over 4 dt. There is no variable t, no big deal. We're just going to go ahead and integrate both sides. So once again, pause the video and integrate. And then compare it with mine. So we get ln of the absolute value of y is equal to 3 over 4t plus c. Notice that I kept the c on the right side and I only wrote 1. So I kept it on the right side. Just stay consistent, okay? Just get accustomed to keeping it on the right side and stay with that. There's nothing wrong with leaving it on the left side if you're thinking that or if you did that. But just pick a method and just stick with it so that you don't start confusing yourself. Your next step is to get rid of the natural log by raising both sides to the power of e. Do not forget those parentheses. You can then break down e to the 3 over 4t plus c to e to the 3 over 4t times e to the c. Then this just is equal to c. It's another constant. So you now have the absolute value of y is equal to c times e to the 3 over 4t. Now from this point, I am going to use my initial condition to solve for c. So plugging in y is equal to 10 and x is or t is equal to 0, I now have that 10 is equal to c. Well, this is just e to the 0, which is just c times 1, so c is equal to 10. So in my previous example, I got rid of the absolute value bars by putting the plus or minus, and I got y is equal to the plus or minus c equals to 3 over 4. That would be the case. However, I have enough information given this initial condition to figure out that c is actually not plus or minus. C is actually positive 10. Okay, because of this computation that we did on our side note here, we can take this a step further and say y is not plus or minus c. As a matter of fact, we know for a fact that it is 10. So y is equal to positive 10 e to the 3 over 4 t. And that's your answer. So y is equal to 10 e to the 3 over 4 t. So if we weren't given the initial condition of 0, 10, our answer would have been that. Y is equal to plus or minus c e to the 3 over 4t. But because we were able to use our initial condition to solve for c, and we actually were able to figure out that c was equal to positive 10, we plugged that in for c. We don't need the plus or minus anymore because it came out to be positive 10. And the answer is this. Okay? That's it for the video.